Here I involved with my supervisor for this in let's say, a new technique. Usually in the additive manufacturing, the feeding of the materials is done by the wires and also the powders. But here we propose such a new techniques. These techniques by direct depositions of the drop ejections from the material cutted of sheets by the laser cutting and then directly deposited on the substrate. And it is very efficient technique here, as we can see. And we preferred in our approach that demonstrated before to use the boiling-driven laser cutting instead of the assisted gas cutting in order not to interact the ejections with the strong gas eject. And also the sheets can be a waste sheet. Therefore, it is enabled to recycling for a very short period. And also here we can see that the depositions can be done within a few millimeters beyond the cut metals sheets. And we can see here for the successful result of this study visibility that can be shown how the drops is transfers. We use the high-speed imaging technique in order to monitor the process, and also the depositions, the cross-sections of the track or glad, and also the impact of the laser upon the top waste sheet metals. And here the schematic representations of this novel technique. Of course, this technique can be also used to tailor such an array materials, for example, cobalt and gold, and also like any other rare materials, and also can be used in the environment where the feeding of the wire and powder it is very difficult. And that's all. I wish that it's successful and recently published in journal paper.